My name is Nitigya Kargeti. I am a data scientist here at Dataplatr, and I am really excited to, tell you a little bit about how we can use AI in our data engineering pipelines and how we can address this engineering challenge that Amit has already previously told us about. So this number, right, 75% is something that resonates with a lot of business people. 75% of the time spent in data engineering is mostly done in repetitive tasks. This is a common problem that we have seen, be it fixing naming inconsistencies, adding metadata, or writing up your incremental load cycles. However, I mean, if you think about it a little, the most obvious solution is pretty simple. Just run an automation cycle and you're pretty much done. Your pipelines are efficient, everything is going fast. So are you in the good? There can be some issues with that. So if you see on the right side, right, we have a little bit of the risks that are involved. Like, for example, you run the automation, but if everything happens on its own without validation, the errors get propagates, they cascade down and go into productions, which can cause a huge issue. This is what is called blind automation and something that we have seen happening in tons of companies that we have worked with. So we were thinking in this new age of agentic era, agentic analytics, what if AI handled all this repetitive work, but you as a human stayed in control? Now, that is something that we wanted to make sure we're able to present in a proper way and the most easiest way possible so that we can even bridge the gap between how the data engineering pipelines are created between analysts and how business users can also collaborate on it. So before we do that, let's first try to understand what the original architecture was, the state-of-the-art medallion architecture. We had multiple data sources, then they get through to data acquisition. And once they're in the data landing phase, where all the transformation happens, that's where the medallion architecture takes place. And this is something that a lot of your data engineering teams are very, very familiar with, where we have our bronze schema, which is the basic source tables. Then we clean it up a little bit and provide some slowly changing dimensions, some row level cleaning, and create a silver layer. After that, we go on to our gold layer, which is the main core and crux where all the different transformations happen, which is cross-functional between different teams, and that goes into the visualization phase. So this was the original architecture, right? But what if we can incorporate AI into this mix? So this is the architecture that we presented, an AI-powered medallion architecture. The main idea, AI proposes the suggestions, humans are the ones who approve it, and no deployment happens without your explicit consent. So how does this work? Well, first, we taken basically what we know. And if you're a software developer, there's a common phrase, which is called, if it ain't broke, don't fix it. So we just used all the different pipelining naming conventions that were already present and just made sure to add in a little bit of AI flavor on top. So on the bronze layer, we have metadata. We're basically adding metadata intelligence on top of our source ingestions. So once your source schemas are propagated inside of Databricks, after that, we can simply use a sample of that source data to generate metadata. And based on those metadata, it can propagate further. Now, why is this useful? Well, let's say that you get a new engineering talent into your team. And I mean, they would be supposedly shown various of different tables, different schemas, and based on just all the different hundreds of different tables that they have to go through, they would have to manually analyze. Okay, what exactly is this? What exactly is that? But if all the tables are metadata enriched, there are already descriptions which are being propagated for all the different aspects. We would know that, okay, the person can easily identify and proceed further to the next step. Then after that, we have our silver layer and the first part of it, which is data standardization. So here we standardize all these data columns. And in addition, we create views, not copies. So you can be rest assured that your memory overheads will be safe. In addition to that, we're also going to provide you with configurable rules. So if a specific standardization rule that follows in your specific entity, You can add those rules, and the AI would suggest the standardized column names based on your specific aspects. After that, we move on to the second silver layer, which is handling of incremental loads and data quality checks. So in this layer, based on all the metadata and data standardization that has happened in the previous ones, we simply use AI to auto-suggest us different keys for the primary flags, for sequence buys, for delete flags, and we have even given you data quality checks like not nulls, all auto-suggested by AI. Everything is configurable, and we will see that once we head to the demo. After that, we head to our flagship layer, which is the goal layer, the business modeling layer, in which you can talk with natural language using Databricks' own AI platforms, the ML endpoints, and genies. In addition to that, it will also give you the data transformation logic and also validate and self-heal the SQL based on your specific needs. So this technically fits how the data teams have already been working. All it does, it just removes the repetitive tasks so your teams can focus on things that are actually valuable, like optimization, how we can, bridge the gap between the actual finance dashboards and the physical layer, all those things. So this is what we are presenting. So without further ado, we can just jump right into the demo and try to see how everything just goes. So if you open up your Databricks' platform, this is something that you will see. So so here's a solution that we have presented, which is working completely on the Databricks' architecture, and it is a Streamlit app built on top of the Databricks' infrastructure that they have presented us with. So when you work with us in Dataplatr, this is something that you will see, an app generated and a link is running. So if we click on the link, let's see what happens. Well, you would be presented with our app's homepage, where all the different steps that we have talked about are mentioned in very easy languages. All you need to do is just make sure your warehouse is connected and you have your LLM endpoint connected as well. Once that is set up, we can simply move on to our metadata intelligence or bronze layer step. So here on the left side, you would see a source configuration panel. All you need to just specify is your source catalog from where you have ingested the data and saved in the Databricks' Unity catalog and what the source schema is. Once those are configured, you can simply just press a button and automatically our system will try to analyze all the tables that are present inside the schema and give you suggestions for the table descriptions as well as the columns descriptions as well. So as you can see, it is now trying to identify all the different tables, trying to fetch different columns and generate the descriptions as well. So once it done, it gives us a very, very very technically rich the comments based on what the table does. So this is an AR cash receipts table. And based on that, it'll tell us, okay, each row represents a unique cash receipt. It also tells us what the analytical typical use case would be and what the important nuances are for anybody who wants to use this table is. And that's how it is generating for all the different tables that are present in your schema. Now, if you just want, so here is where human in the loop comes into the picture. Let's say that you're kind of happy with the first paragraph, but you also want to write something else. Well, this entire thing is fully modifiable. So you are able to write your own comments and add on top of anything that AI suggests as well. Or you can delete as per your liking. And once you're ready, simply just select the column and just click on apply. And you're all set. The same thing happens for our columns as well. So it suggests all the different columns with the data type as well on what exactly that specific column is doing. Now, in addition to this, to also make sure that we're maintaining transparency and also compliance and governance, we're also providing you a way to change all these different factors that the LLM is suggesting on. So you're also given the prompt and you're able to modify the prompt as you're liking. So if you're specifically want to change anything, you can do that as well. And once you're happy, we can move on to the next step, which is silver layer 1. So Once we're in this data standardization layer, you would see things are looking pretty similar to what we have in the metadata. And yeah, we try to create the system so that business users as well as data engineering teams can use it alike. So you can simply have to just configure your source schema and your source catalogs again, your target catalog, your target schemas, where you want these specific tables to be generated in the Unity catalog, a specific naming convention that if your organization supports those things. So this is just for this because from this step onwards, we're going to be generated SQLs as well, so that everything is fully compliant and everything is fully visible for a normal user as well. And after that, you just need to provide a SQL output folder path. Now, this could be a Databricks repo, a workspace repo, or it could just be a GitHub repo as well. So we can simply, again, just press the load else or tables. It'll then try to automatically analyze and try to create the SQL files. Now, we also want to be sure that we are not burning through your precious LLM tokens. So if a SQL file already exists, we're also making sure that we're not touching them, and we're only going to work on things that are not present in the system. However, if you want to regenerate a SQL, you are also given that option as well. So once it's done finding all the different SQLs, it'll identify, okay, these SQLs existed, and this Oracle user schema was not. So then it'll try to generate the data standardization on this specific layer. And voila, we have our SQL ready. Now there can be another question that how can I trust that the SQL is valid, right? Well, we're making sure that we're testing out each and every SQL that is generated and shown to you. And if any SQL has any problems, it will also self-heal and give you the proper and correct standardized SQL every single time. In addition to that, the same as our bronze layer, we have all the different column standardization prompt here as well. So all the different standardization rules that we're using here, like for example, for last created data is changed to when modified, and all the different standard procedures that we have learned and as we have experienced over experience in the data analytics space over the past decade. That's what we're using here. However, if you want to change something, we have given you full access so that you're able to change the rules as per your liking. So once you're ready for that, the process is the same. You simply just press approve and just save the SQL file. So once it's saved, right now it's getting saved to a Databricks workspace repository. But as I said before, we can also add a GitHub repository as well, based on whatever you're using. And to make your process even easier, you can simply deploy a Databricks job right from our system itself. And after that, it'll give you a link to where you can monitor this job running on the Databricks environment as well. Now, this is a specific custom code that we have generated that will give you a full report of all the different tables that are being generated, which one failed, why it failed, so that you can have a full audit trail of your entire system till the standardization process. So we'll just wait for it to run. It takes a little while. And once it's done, we will see that, okay, all the different tables have been generated in our Unity catalog, and it gives us the final report as well. Okay, now moving on to Silver Layer 2. So the process is exactly the same. The only difference is that in this specific layer, where AI is suggesting us different column names, which can be used for all these different incremental load cycles, sequence by keys, delete flags, and also data quality checks for not nulls. So you just need to configure, tell us where the SQL will be stored, and just press the button. Now, once you're ready, this table will simply just help us suggest. It will give us a little table description, which was generated, and it will suggest us what the primary keys are, what the sequence by key should be, what the delete flag should be, and everything is fully modifiable. So if I did not want org ID, I can remove that. If I want a system ID, I can add that. So based on all those things, it automatically regenerates and gives us suggestions. And once you're happy with it, we simply, again, do the same thing. Just generate the approved SQL file, and it'll run. Now, after this step, right, this is where it is generating a Databricks declarative pipeline, which is an easy way to make sure that you can have a full ETL pipeline with directed acyclic graphs and the full lineage being tracked properly. So we can simply just press a button. It'll create a pipeline, ETL pipeline for us on the Databricks space, and we can simply just run this pipeline as need be. And once this pipeline is generated, you would see the entire graph being generated up onto this point. This is the place where we have made sure that that everything else is in the same space. And Databricks also helps us with providing a very intuitive UI so that you're able to access everything pretty easily. Okay, so once this is done, we can simply move on to our final step, which is our final layer, which is our goal layer 3. So the way that this system is working is that you'll need to configure everything the same way that we have done previously, like simply just mention the source catalogs, the target catalogs, the schemas, your output folder, and then you simply initialize the agent. Now, this is a UI that you're seeing, which is a little different from the others, because now you can chat with the agent in natural language. So the way it works is you simply ask it and creating a specific table that you're requesting. So let's say, because the type of data that we have, I'm going to say create a customer 360 journeys table. And I just press send. Now the agent will think. Now, at this step is something we want to, again, and tell you a little bit about why we're incorporating human in the loop. Technically, the LLMs are powerful enough that it can literally generate the entire SQL, the transformation logic, all fetching all the different schemas in a single step. But we want to make sure that humans are the ones who are in the control seat. And this specific UI gives you access to that, as well as a collaborative space between you and AI, so that you can work together to build the proper and correct tables. So right now it is asking me consent for if it should be able to look up the source tables. So if I say, sure, proceed, it'll then try to proceed and then try to understand which specific schemas are present and which specific schemas are appropriate for a customer 360 journey table. So it has suggested us a couple of different tables, what it thinks gives us the best value for a gold layer table. So once, if you're happy with it, you can simply just say, okay, sounds good. We can move on. And then it'll try to understand the detailed schemas, what these tables contain, the column there, and everything else in the middle as well. So once this is running, after that, it'll tell us all the different columns that are needed. And in addition to that, it'll also let us know which are the specific columns and what the proposed transformation logic should be. Like if we should do a left join on cash receipts all table from this specific column, and then what the other join should be. If you're happy with this transformation, you can proceed. Or if you want to add something else, you can do that as well. But for the sake of time, we're just going to proceed with this specific use case. So once we go further, it'll then try to understand and try to generate a SQL. And in addition to this, again, just the same way that we have been generating proper SQLs, this also has the self-healing logic, where if the SQL which is presented is not appropriate or is not compiling, it'll make sure that it'll reiterate based on that and give you the proper SQL as well. In addition to this, because Databricks has given us access to all the different logs, it also gives us access to all the different things that this table is doing, what tools are being called, and we have full audit trail as well. So everything else is fully auditable, and you would know exactly what is happening at each step. Nothing is a black box at this point. So we go back to our goal there, and as you can see, we have generated a very, very complex SQL. So we can simply validate it to see if it's working. And there we go. The SQL is validated. Now we can deploy it. And once it is deployed, we can simply just go back to our ETL pipeline and run it based on our systems. So that is a little bit about the demo that we have presented. And based on this, you can run these ETL pipelines and get all the different tables out in a matter of minutes. So that concludes us with our demo. Now, what you've seen right now is the entire medallion architecture going in a matter of minutes. If this was a traditional sense, we would simply have taken most likely weeks, if not months. So this is how we can accelerate your workflow, and this is something that you can do as well. And we're happy to help you on that. So now we're moving on to another poll. This is a question actually I'm really excited to ask as well, because working with AI for so long, I also want to know which areas of your data pipeline you think can be most assisted by AI. Writing transformation SQLs, validating SQLs or self-healing, updation of the documentation of the pipelines, or like a data lineage discovery and understanding based on the pipelines that you already have. So we'll wait for a little while you answer, and then we'll try to see the results. Here's the results. Okay. It seems like a lot of you are really interested in a lot of things based on AI. So writing transformations to SQLs, that's a very valid point. Validating these in self-healing, again, very appropriate. Data lineage and discovery and understanding, and evolving pipelines. Well, you're actually pretty on the spot. And if you see from our demo, and all of these different steps are being covered by our cycles and our pipelines. So you can also make sure that you are entering this world of agentic analytics properly.